Will your next home be a bioceramic dome? Welcome to Tech First with John Gutzier. Bioceramic is a pretty interesting material, and I'm really excited about this interview because I've always been a little bit of an architecture geek and love unconventional ways of building homes. And this is a really, really neat one. Uh, Bioceramic is fireproof, doesn't mold, doesn't rot, doesn't rust. Making it can be carbon neutral, and you can build it in a geodesic dome shape. So I'm going to chat with somebody who's actually doing this right now. His name is Morgan Bierschenk. He's a CEO of Geoship. Welcome, Morgan.
Hey, thanks, John. Nice to see you.
Awesome. Super happy to have you with us. You are sheltering in place in your home office, I guess. Are you okay during COVID-19? Everything fine with you?
Oh, yeah, we're doing great. Really good.
Awesome. Now, talk to me a little bit about Geoship. What is it? What are you doing? What are you building?
Yeah, well, so the name is a pseudonym for the Earth, really Buckminster Fuller's kind of view of spaceship Earth. What we're doing is using a new ceramic material science and new production technologies to make all ceramic homes, starting with the geodesic dome.
Very, very cool. Ceramic sounds like to us a very fragile material, but it's actually the what I've seen from the details that you provided is actually extremely hard with a tensile strength that's harder than concrete. Is that correct?
Yeah, so this is it's a new type of ceramic, a new family of ceramic materials called chemically bonded ceramics. So they're technically an inorganic polymer. So they have the many properties of a polymer and that they form molecular bonds with metal and wood and with themselves, but the properties of a ceramic and that they're highly crystalline and covalent and ionic bonding, and the properties of a cement and that it's a water activated powder that doesn't require high heat.
Very, very interesting. So there's some examples in the background behind you. That is a green screen behind you, as you told me earlier. I added some examples in the preview picture as well. Why the dome? Why the geodesic dome?
Well, it's when Buckminster Fuller was building domes in the 60s and 70s, he said that it would be, he called them wooden spaceships, right? Like the right geometry but the wrong materials, and he kind of guessed that it would be 50 to 100 years until the right material sciences arrived to really produce geodesic domes, and so now we have the right material science, and when you can produce all ceramic building panels like this, the geodesic dome just has so many advantages over a rectilinear structure that it's a cost-effective and resilient and modular and just a logical place to kind of start, and also a good kind of niche for a home building company because we don't want to.
Absolutely. So I want to get into that. I want to talk about the cost, which is really interesting. I want to talk about the environmental impact, the durability, how you build it, and all that stuff. But before we get into that, maybe we can talk a little bit about kind of your journey. What got you interested in this? Why you started building these, or even got the idea from? Where'd that come from?
Yeah, so I guess it really began in 2004 for me. I had sort of a transcendental experience while I was backpacking around Asia and India for a couple of years. I left my corporate job at Intel and just started kind of cruising for a while. And that experience led to the next 10 years of really looking into how can we create environments, including the physical environments around us, as well as the way we think about the world and our relationships to our friends and community, to kind of open up the possibility for those deeper experiences of just being alive. So that, I would say, that kind of sent me on a journey. And then before founding Geoship, I lived on a wooden sailboat for about 5 years, just learning to sail and also just experiencing kind of a regenerative home in nature. And then I started doing a lot of work in Iceland on freedom of information projects, really focused on liquid democracy platforms and alternative forms of currency. And then I came home and started building a regular house with my brother, and he's really like a builder, inventor who has been in kind of the CNC mold making world for 20 years. So we started thinking about new ways to build and started Geoship.
Interesting. Wonderful. So let's get into the material science, and what you're and how it's built, and all those sorts of things. I actually, interestingly enough, I have a friend, who is a city planner. And I asked him, if I showed him some of the materials just earlier today, and I said, "Hey, would this be legal to build here in our community, in our city? Would this be would it pass planning permission, all that other stuff, right? Meet the code?" And he said, "Absolutely. If it's constructed offsite, we'd probably have to get some more details to make sure that it's there's quality standards or something like that." But I was actually surprised to hear that, and super interested as well. So talk to me about, the construction. What's it look like? How's it work? Is it on site? Is it off site? Is it mass produced and then shipped? How do you build it?
Yeah. So the technology, it's a precast technology. So we're precasting these all ceramic building panels and ceramic frames that then get flat packed and arrive on site and can be assembled really quickly by.
It's the IKEA of homes.
Yeah, I mean, it really is like a bunch of pieces that can only go together one way. And one of the ways that we kind of make it more, one of the reasons why it's so much more affordable, potentially so much more affordable, is because basically all the building products that are used today are all being replaced with ceramic composites that we precast from precision molds.
Interesting. Interesting. Very, very cool. So you said it could be quite a bit more affordable than what we have right now. What does that look like? What does that mean?
It means, the initial costs or prices as we out of the gate will be slightly less than like a conventional wood house in California, but it's a production technology, right? Like there's a potential or we will enter onto a whole new affordability curve. And I mean, if you look at, how houses have been built for the last 100 years, we've really been building like rectilinear houses out of metal, wood, and concrete. There's been a
Yes.
lot of innovations with power tools and plywood and, better screwdrivers, a lot of little things, but still like at a really foundational level, it's like that technology has kind of reached maximum yield. I mean,
Yep.
the cost, like house price to income ratio in the 1950s was lower than it is today. So, we really need kind of new production technologies to break into a new affordability curve.
So let's talk about that then in with real numbers. You said approaching the cost or somewhere near the cost. Let's say that you're building maybe a smaller house by
Yeah.
today's standards. Let's say it's 2,200 square feet or something like that. And you want to replicate that kind of experience with this technology. What kind of construction or materials cost are you looking at?
That size range probably in the like 130 to $160 per square foot range, like totally turnkey price.
Interesting. Turnkey, as in somebody comes and assembles it for you?
As in, yeah, somebody comes and assembles it for you and installs all the cabinets and countertops and appliances and HVAC systems, everything.
Interesting. So this is not just a shell that you're buying. This is a complete home with everything in it that you would expect to have it with your closets and your kitchen cabinets and all that stuff.
Yeah, one of it's like the shell is the core of the product, and then there's a whole kind of product ecosystem that we're building around the shell for different configurations and cabinets and countertops, and even partnering with a lot of different companies for HVAC and electrical systems and stuff like that.
All of which I guess looks a little bit different than normal because it's a different kind of construction, right? It's not like you've got 2x4, 2x6 walls and you can hide wiring in that, or you can hide ducting or something like that. Is that correct?
Well, you do basically have 2x6 walls, except the frame is a piece of ceramic, and on both sides is a piece of ceramic with ceramic insulation, so cellular ceramic insulation. So you can still, run wires and ducting and stuff like normal, and you can actually, these ceramic composites are really interesting. I mean, we can make ceramic composites that are 5 pounds per cubic foot, so really lightweight, or 140 pounds per cubic foot, really heavy, and make them so that you can cut into it with a saw, like a piece of wood. We can make the ceramic frames the material is about the consistency of oak. It's about 60 pounds per square foot and cuttable. And so there's just a lot of ways that you can, add different aggregates essentially to the ceramic to make different qualities of building materials.
Sure, sure. Talk a little bit about the durability in terms of natural impact, perhaps pests or other things like that. What are you seeing? What are you building? What are you constructing this for in terms of durability?
So we're building for a design life of 500 years. So
Wow.
building homes that we expect to be around for at least 500 years. One of the unique parts about the material science is like, if there's damage, like say projectile damage of some sort, you can actually just mix ceramic on site and patch it as a waterproof permanent patch.
Nice,
And you can also spray the ceramic like a paint, a real thin layer to like resurface the whole thing.
nice.
So those properties kind of enable, more longevity. And then on top of that is, yeah, the embodied energy of the ceramic materials are really low, potentially even carbon negative. So
Wow,
actually sequester more CO2 than was released in their production.
wow, wow. Interesting. Do you have a traditional style foundation for a home like this, or is it different?
You could do a traditional style foundation, or kind of the foundation that we lean towards is one that it basically has the same ceramic panels as the flooring, and we use helical piers in the in like 5 or 10 points around the dome, depending on which size dome we're talking about.
Yeah, yeah. Interesting. And I want to talk a little bit as well about what you hinted at earlier. And that is that, and there's a question here from Steve Berman. Steve, I'm going to get to you in a second. Um, you hinted at there's different ways of living than what we've had in the past. And I've seen some of your materials. Right now, most of us live in a box, either stacked with other boxes vertically in a high rise, or a box that's put down on a square of land. And there's another box next to us, and there's another box across the street. And there's these different boxes. And you talked about your experiences while leading you to that, a different kind of community based on this kind of architecture. Can you go into that a little bit more?
Yeah. So, Geoship is structured as a multi-stakeholder cooperative. So we're actually distributing equity to customers and to nature through and that how you distribute equity to nature is basically through this personhood for nature movement that's blossoming now. So a little different corporate structure, and then also our business model, right, is to ultimately our business model is to bring communities together in a virtual space. So somebody can go onto our website and say, okay, I want to build a community. You gather your friends together, you design a village, so you have a really clear vision of what you're moving towards. And then we work with that community and take them through the whole design build process.
Wow. Very, very interesting. Very interesting. Mention your website for a moment so people can go take a look at some of those pictures.
Yeah, it's geoship.is.
Geoship.is. Obviously, you were in Iceland for a while, so I guess that's where the IS came from.
Yeah,
It is super interesting because it looks like a more organic arrangement of material of buildings, and rather than sort of on a grid, you can create more social spaces than what we have done traditionally in North America. It's interesting. I was in Barcelona recently before all travel got shut down, and they do have a grid, there's no doubt about that, but they also have these larger spaces where people can gather and just do things in the middle of their city, and it's really wonderful. I
yeah,
do have a
exactly.
question I'm going to pop up on the screen here from somebody who's watching, Steve Berman. He says, I'm a materials engineer with a focus on ceramic science. What are the specific materials you are suggesting? Can you talk about that a little bit?
Yeah, so we're setting up basically a geopolymer precast plant. So a lot of different formulations could be used in the plant, but the primary one we're talking about is a chemically bonded phosphate ceramic.
Interesting, interesting, wonderful, good, good, good. So I mentioned that I had talked to a city planner this morning, and kind of sight unseen, I sent over, your website, so he kind of took a look at that. I'm assuming he said, "Hey, that wouldn't be a problem, not a problem." Talk about permitting in all other jurisdictions. What have you learned about that? What have you explored about that?
Yeah, so we're designing the domes to meet the international residential building codes. It's different, a lot of the alternative natural building techniques out there, like filling a tire full of dirt or straw bale and cob and whatnot, are um, they can't really fit them into the existing model. But with our technology, they know what a geodesic dome is. They know what high strength fiber reinforced alternative concrete is. So meets as long as the structural engineer stamps it off, and there's not like codes for the like neighborhood covenants, that
Yes.
restrict the look, then meets the building codes.
Very, very interesting. Talk about maintenance. Is maintenance different? You mentioned being able to spray another thin layer of the ceramic, bioceramic onto the material. Do you paint it? Do you leave it? What do you do?
You just wash it once once in a while. But the material is fireproof to about 2,300 degrees. So it's where we're based in kind of Nevada City, which is sort of the heart of California fire country. So we see a beautiful opportunity to build more fireproof architecture. And then also because there's not, the interior, the exterior, and the insulation are all these ceramic composites. There's nothing to rot or to corrode. There's nothing for insects to eat. So potentially
Very,
really well.
very interesting. Very interesting. Talk a little bit more about the environmental cost of traditional building. You mentioned that it's carbon neutral, maybe even carbon negative to build something like this. How does that compare to a traditional put frame construction, wood frame construction building?
Well, so the embodied energy calculations of conventional construction there's a lot of variables in it, so it's more of a art than a science. But they say somewhere between 80 and 300 tons of embodied CO2 in a typical wood house.
Wow.
The embodied CO2 in a bioceramic dome would be somewhere in the like 3 to 10 ton range.
Wow.
And potentially negative when we can actually, in a precast plant, you can cure the panels in CO2 rich gas environments, and all that cellular ceramic is a lot of surface area to sequester CO2. So you can kind of, normal CO2 sequestration process might take, decades, but we can accelerate that in a precast plant.
Very, very interesting. You mentioned briefly that you're structured as a collective and that people who buy one become sort of shareholders in a sense. Can you talk a little bit about that as well as what the process is and kind of the stage you're at? Like, is that possible right now? Is that possible within the next 6 months? Where are you?
Mm-hmm. Yeah, we are about halfway through an equity crowd investing campaign, which people can check out on Start Engine, and there's a lot more information about the product and business model there. So that's kind of one way that we're starting the company in a way that aligns with our values, right? Just making the investment opportunity as little as $300 to open to everybody. And then in addition to that, at some point in the future, probably in the like 2 to 4 year time frame, we'll actually distribute equity to customers and to nature.
Very, very interesting. I have a really long comment I'm going to shoot up here from Steve Berman again, and I'm going to have to connect you with him. He's a Facebook friend. He says, "What's the cost? We have 16 acres as a test ground if you want to build a showcase. Our NASA award-winning educational nonprofit offers an innovation summer camp." So I'll drop that off, and I can make a connection later. But I'm assuming you have a test site as well, but I can connect you if you're interested.
Yeah. One of the partnerships we've been building over the last year and a half here has been with Zappos, the corporation in Nevada, and the City Repair Project up in Portland, to really design transitional villages for people going through homelessness. So, and that is a really interesting way to build a village from scratch, because a lot of those things you mentioned, like we don't have common places in our villages. Well, there's a whole science around that called place culture, right? So how do we bring the basics of like, a community center and a weave of paths and different qualities of space for different types of activities, and really use the physical environment in a way that just enhances community and cooperation and connection to one another in there.
I love that. I love that a lot. And there's a lot of interesting work being done in innovative ways for building new communities, right? And some of those are around homeless people, which I'm super happy to see. And some of that is like shipping containers or tiny homes set up in communities. We've also seen some innovative ways of building communities designed for older people who are alone often, and they can be together in different ways. What seems interesting about the way that you're building is that it looks to me, and I'm looking for you to confirm or deny this, that you ought to be able to design these domes in many different sizes and configurations, so that you could have a family-sized dome, or you could have an individual, or even a smaller, maybe even a workshop attached to yours, or something like that. Is that correct?
Yeah, yeah. There's a lot of different ways to use them for kind of auxiliary dwelling units of different types, and the first kind of set of products that we're building is 3 different size domes that range from one's 200 square foot to 800 square foot to 1,400 square feet. And then you can connect those in many different ways. So I think, generally a single family geodesic home will be 2 or 3 domes, not just one big one.
What I love about that, and what I've kind of thought about a little bit, is okay, here's the main dome, the maybe family area. Here's maybe the master bedroom dome. And here's maybe the teenage dome or something like that, right? And you can kind of have different living spaces and a little bit of space, but a lot of common area as well.
Yeah, and modular, you can add another dome later. That's one of the interesting, there's a model out there around what they call the Hobbiton Ring model, right? It's like how to build a village where as you move through different stages of life, you move to a different home. Because, we start out single and then we get married and then you have kids and then it goes back small again as we get older. So the house has to be able to evolve, or the places that we live in change over time.
Very, very, very interesting. Wonderful. I want to go back to the beginning here just for a second, because off the top, you said that you left your job at Intel to go and travel the world and other things like that. What did you do at Intel?
I was in a rotational program for 5 years. So I was doing, programmer analyst and industrial engineering and project management and knowledge analyst, a lot of different roles.
Interesting. Interesting. Well, Morgan, I want to thank you for taking some time. I really do appreciate it. It's been a real pleasure having you on Tech First, and thank you for taking the time.
Okay. Yeah. Thanks so much, John. Really appreciate it.
Excellent. Excellent. For everybody else, thank you for joining us on Tech First. My name, of course, is John Kutsier. Appreciate you being along for the ride. Whatever platform you're on, please like, subscribe, share. And if you're listening to the podcast afterwards, hey, please rate it, review it. That'd be a great help. Thank you so much. Until next time, this is John Kutsier.